Hey, y'all, so this is test 4 review. So the first 3 problems here, we're dealing with graphing. The first one, we had to graph a function. And then number 2 and 3, we had to sort of describe how the transformations of a function. So the first one wants me to graph y equals 1/6 to the x power. So these are the exponential graphs where the exponents are the variable. So I'm just going to draw a little X and Y graph real quick. Now, I'll show you on the calculator. You can knock that out pretty quick on the calculator also. So this would come from our section 9.3 where you had the graphs. The fractions, when we graph them, you'll notice they'll sort of go downhill. So I'm going to make a table for us. So a number I would definitely use for x would be 0. Because if you remember, anything to the 0 power equals 1. So no matter whether that's a fraction or a whole number, if that exponent is 0, then that y value will be 1. So all these graphs, unless we move them around, are going to go through that 0, 1 point. So now I would probably use 1. That's an easy number for an exponent. So this would be y equals 1/6 to the first power. Well, anything to the first power is going to be itself. So that's going to equal 1/6. So 1/6 ain't very high on this, and it's not shown over here because I'm going by ones. But 1/6 will be just a little bit up and then a point. So this side, what it's going to do is it's going to sort of come down and try to get to that x-axis. But y'all, it cannot cross the x-axis because there's nothing I can do to that exponent to make this positive fraction become negative. So it's going to do one of them horizontal asymptotes over time. So let me try a -1 so I can see what might happen on this side of the y-axis. So y'all, if we put a -1 in for that exponent, I get negative. I got a negative exponent. So my first step would be to make that exponent positive. And to make an exponent positive when you got a fraction, you flip that fraction. So that'll become 6/1 to the positive first. So it's just like when you had a whole number. If you had a negative fraction, you flipped it and put it under a 1. So fractions, we're doing the same thing. We're flipping them and making the exponent positive. So this is 6 divided by 1 is 6 to the first power is 6. So when that's a -1, my y value is 6. So that'd be over here at -1. So that's 5. So 6 would be probably right up in here. And then if you put a -2, you would flip that, which would create 36. So at -2, it'll be way up here at 36 already. But it's going to come down, sort of go through 0, 1. And like I said, try to hug the x-axis. And they're going to give you 4 pictures to choose from on that one. So this one sort of goes up and over. This one looks like what we drew, comes down. This one, it crosses the x-axis, so there's no way it can be that one. And then this one's sort of backwards. Okay, so your question 1's going to have a B, C, D choice on it. Now, if you wanted to do this on a calculator, I would just go, let me share that calculator real quick. I would just go to my y equals. Now, the fraction has to be in parentheses like it is in the problem. And then do 1 divided by 6. Close parentheses, and then do the exponent of a x. And y'all, when we graph that, we should get pretty much the same picture. Comes down from the left, crosses over at 1, and just sort of hugs that x-axis. And really, all these can be drawn on your calculator. All right, so number 2, they want me to describe the transformations. All right, so they're giving us f of x equals 2 to the x minus 1. So here's the thing. When you attack those exponents like that by adding and subtracting them, that's going to create a horizontal shift. It's going to move you left or right. So remember, if it's positive, it moves left. If it's negative, it's going to move to the right. So you'll come in and you'll say, start with the graph of y equals blank to the x. Now they put the x here. All we got to do is put our base in this block, and then we got to tell it what we're doing. So we're going to shift it 1 unit up, down, left, or right. So we got to figure out what we got going on. So the first thing, we got to put our base here. Well, my base is a 2, so that's the number in front of the exponent. So I'll throw a 2 in there to the x. Now, y'all, they already put the x there, so make sure you don't write the x also, okay? Now, we're subtracting 1 from the exponent. So when we subtract 1, we just said right here, we're going to move to the right. So that's going to shift it 1 unit to the right. All right, so now you have to graph this in MATLAB. So let me tell you what I would do in MATLAB to get this graphed. So the first thing we're going to do, we're going to choose the tool that looks like the exponential. So that's your exponential tool. So choose that and then click on graph. Once we click on the graph, it's going to put that exponential looking graph on the page, okay? So now we got to tell it how we want to move it. Because once you click on the graph, it's going to open up that other box. So since we went 1 unit to the right, we're going to hit the horizontal slider. And you're going to slide it right to the +1. And y'all, you got to remember this also. Change the base in the bottom left corner. So for that one, they're going to have a little box down here, and it's going to say base. Remember, we have a base of a 2 here, so we need to put a 2 in that box. By default, that has a E in the box, okay? So make sure you change that to a 2. All right, y'all, question on that? All right, so the same thing for number 3 here. Number 3 wants us to describe the transformations. And y'all, this time we got f of x equals 2 to the x plus 4 minus 3. So we got 2 moves on this one. Remember, that +4 on the x is going to do me horizontal. This -3 is going to do vertical. So on vertical, if it's positive, it goes down. I mean, my bad. If it's positive, it goes up. If it's negative, it's going to go down. And the same thing on the horizontal up here. The horizontal is positive. So remember, when the horizontal is positive, it's going to go to the left. So we already know what that one's going to do. Now this subtracting 3 is going to bring me down 3 units. So you'll have to say, start with the graph. Y equals blank to the x. So my base on this one's also a 2. So I would put a 2 into blank. And then shift blank 4 units. And then shift blank 3 units. So y'all, let's see what y'all think on this one. So this blank, it wants me to shift something 4 units. That 4 is hitting that X up there. So what would y'all put in that? Up, left, right, down.
Left.
So that is definitely left. And then shift it blank 3 units. Down, up, left, right.
Down.
And that'll be a down. Hey, y'all, so that's what you had to do on those first 3. Now, this one, we have to graph it also. So Math Lab, once again, you're going to choose the exponential tool and then click the graph. So your horizontal has to move left 4 units. Your vertical, now on the vertical, you go left to get to the -3, okay? So remember, left brings you to the negative numbers, right will take you to the positive. Oh, I need to put my negative there, right? We went horizontal left over to -4. All right, once we do them 2 moves, also remember the base. You have to change the base. So once again, mine's a 2, so I'll have to put a 2 in that box. Because y'all, I'm telling you, if there's an E there, your graph will look just like your graph will look, but they'll be off by just a little bit, and it's hard to tell because they're just going to be off by very small amounts, okay? All right, 4 is a word problem. So on Melissa's 6th birthday, so her 6th birthday, she gets a $5,000 CD. The CD has 4% interest, and it's compounded semi-annually. So this CD matures on her 10th birthday. So the question is, on that 10th birthday, how much money will be available? So we had a formula we used in this section. And that formula was A of T, which means the amount at any time T equals P, which is my principal balance or my starting amount, times parentheses 1 plus R divided by N raised to the N times T exponent, where R is my interest rate in decimal form, N is the number of compounds per year, and then T is the time in years. So we're going to use this formula to see how much money will be available on the 10th birthday. So y'all remember, R is my interest rate. We need to turn that 4% into a decimal. So y'all, you'd have to move that decimal left twice. So we're going to have to add a 0 and make that a 0.04. What would N be? Because it's compounded semi-annually. So what would y'all put for N on semi-annually?
2.
So that's definitely 2. And y'all, they use semi-annually a lot, and they like to use that quarterly one, which would be 4. All right, so now let's figure out what t is going to be. So you got to figure out how many years passed in between that 6th birthday and that 10th birthday.
4.
So that'd be a 4. So y'all, we got everything we need, so let's plug that in. So we're finding a of 4, since that's 4 years. So my P was my principal balance, which is that 5,000. Parentheses, 1 plus my 0.04 divided by 2 for my N. And then up here, N times T will be 2 times 4. Now we got to round it to the nearest cents or 2 decimal places, okay? So y'all, I just punched that on my calculator like it looks. So let me pull my calculator up. All right, let me get back to the main screen. So second mode to quit. So we had 5,000. And then parentheses, 1 plus 0.04 divided by 2. Close my parentheses, and then my exponent. 2 times 4, so I can just put an 8 there. All right, so remember, we're rounding to the nearest cents. So y'all, let me fix my mode real quick. Let me go back to float. All right, so when you do it on the calculator, it's going to look like that. So rounding it to the nearest cents, so I got 5,858. So that's a 2, 9. Ooh, the 9's got a 6 behind it, so it's going to round up to a 0, making that 2 a 3. That's going to give me 30 cents. So 5858.30. So y'all, here's your formula. You definitely want that formula right there for number 4 on your review, okay? All right, so now number 5 wants me to find the log. They're giving me log base 10 of 0.01. So y'all, here's the thing. A log base 10 is the same as a log of 0.01. And we got that log button right on the front of that calculator. Big old LOG right next to the, what is it, the 5 or the 4? So y'all punch in the log 0.01 and see what y'all get.
-2.
-2. And if you got decimals like that, you're going to end up with negative logarithms, okay? All right, y'all, number 6, find the log. This is the log base 6 of 6 to the 4th power. So y'all, here's the one where you got the base of your logarithm matches the base of your result raised to an exponent. Anytime you get that case, that answer will always be whatever that exponent is, as long as those two match. Now, I'm going to show you 2 different ways on the calculator. The first way, if you got a newer calculator like a TI-84 Plus or the new TI-84 CEs, on those calculators, you hit math and then you arrow down to log base. And when you punch in log base, it'll give you a log. You'll put in the base and then the number with the exponent. Hit enter, it'll give you an answer of 4. The other way is if you got an older calculator and it does not have that log base feature, you're going to do what we call change of base. So to do that, you take the log of the result. Well, the log of our result is 6 to the 4th. And you divide that by the log of the base which is a 6. So y'all watch me. I'm gonna show you that change of base real quick.
And what the first one would be for the calculators of what age?
The newer one, sort of like the one that I got on the screen here. TI 84. I'm using a TI 84 plus. If you got that feature, what you'll do is you'll hit math and then arrow down here to log base. And that's the A on mine right there. So I would hit enter. And then I would put my 6 there, arrow to the right. I would put my 6 exponent 4 there. And then I would exit out of that and hit enter. So it looks just like I had on my problem, and I get my 4. Now, if you got an older calculator like a TI 83, you would do this, like I said, take the log of the result, which is the 6 to the 4th power. All right, arrow out of that, close those close the parentheses, and then divide by the log of the base of the logarithm, which was the 6. So a little more work if you got an older calculator, but look, when you hit enter, you're still going to get a 4 on that, okay?
Okay. With the TI 83 plus do the same as the TI 84 plus?
I'm not sure. Depends on if your operating system's ever been upgraded. If it hasn't, you'll have to do this change of base to it.
Okay, thank you.
Okay. All righty, y'all. So that puts us on number 7, find the log. So a bunch of these in a row want us to find the logs. So I got log base 16 of 4. So newer calculators, I would go to my log base for that. If you got the older one, like I said, change the base. For the older calculators, you would do the log of 4 divided by the log of 16. So y'all, with one of y'all got a new calculator or an old calculator, what do y'all get on that?
0.5.
Oh, you said 0.5? So I don't want a decimal. So hit that math and enter twice and see what you get. So let's hit that real quick. Let me share that real quick. All right, so for that one, new calculator, you're going to hit math, arrow down to log base. And then you put in your base, which was 16. Arrow right, put in my result, which is 4. And y'all, when I hit enter, I get a decimal, but they want you to write the answer on this one as a fraction. So you got to hit math. One's highlighted for fraction, and you just hit enter twice, and you get a 1/2. Okay, the older calculators would do log 4, which is the result, divided by log 16, which is that base, those parentheses, and guess what? They're going to get a 0.52, and they would have to turn that into what, a 1/2. All right, number 8, find the log. Now, I'm hoping y'all don't need a calculator for this one because this is a log base 39 of 1. And there's only one exponent that's going to turn that 39 into a 1. So what would that be?
Would it be 0?
It is going to be 0. Good job. So y'all number 8, I don't care what base y'all got there. If they got a 1 there, you better put me a 0, okay? All right, y'all. So 9 says convert to a log equation. So 9 and 10 will both be doing that. So they're going to give me exponential. I'm going to write it as a log. So I got 10 to the exponent 6 equals 1 million. All right, so if you write it as a log, you're going to write log. The base is the 10. So the base of the log is the same as the base for the exponential. The result is going to be the 1 million. That's going to equal my exponent, which is a 6. So remember, the log stuff equals those exponents, okay? All right, y'all, same thing on this one. Convert to a log equation. This one, they're being a little trickier. They got an e to the -5 equals little p. Now, if they give you little p, you got to put little p's on these answers, or capital, write them capital, okay? So I'll start out with my log. My base is the e. My result is the p, and that's going to equal that exponent of -5. But y'all, let me tell you what, this one would probably be better to go one more step. Because what does a log base e equal? Well, y'all remember, log base e equals the ln, right? So rewrite the log base e as the ln of p equals -5. So y'all, that's two things you got to sort of get used to. The log base 10, we can write as just a log. The log base e, we write as a ln. And y'all remember, that's the ln, not a capital I, okay? Some of y'all are missing that on homework by putting an I there. All right, now we're going to go the other way. We're going to start with logs, and turn them into exponential. So we're going to convert to exponential. And so this is what 11 and 12 will be. So this one has a log base 3 of 27 equals 3. So to write it as exponential, there's my base 3. My exponent is a 3, and that's going to equal that result of 27. And y'all, that's true. 3 times 3 times 3 is 27. All right, same thing here. Convert to exponential. Oh, let's see what I got here. I got a log base n of a capital R equals a -y. So if you notice, they give you one that's easy to figure out, and then they sort of give you one with these letters where you can't really do nothing to but put them in that order. So y'all watch this. Base is the n. Exponent's that -y. And that's going to equal my result of my R. And doing this kind of stuff was getting us ready for those equations we did in 9.6. Okay. All right, so 13 actually says use a calculator and figure out the ln of 535.4. Now, we need to round this 4 decimal places. So let me share my calculator here. LN is going to be right on the front of your screen here. So the LN is over here by the 4. So push LN and then put in your 535.4. Hit enter. So we got around that 4 decimal places, which looks like what, 6.283. The 0 has a 1, so it's going to stay at 0. Now, watch this. If you have trouble rounding stuff, watch this. I'm going to tell my calculator to round this to 4 decimal places. To do that, you would hit that mode button. Arrow down to where it's float. And that float means it's going to give you all the decimals. So go right over here to the 4. Since I want to round 4 decimal places, I'm going to go to the 4 and hit enter. So now, when I quit that screen, that 4 is highlighted. So watch this, when I hit enter, I get 6.2830 rounded off to 4 decimal places. So the calculator is pretty nice. You just got to sort of figure things out on it, okay? All right, 14 says use change of base to evaluate log base 4 of 30. So change of base, if you got the older calculators, if you got the new calculators, you'll do the log base to it. So go to math and then go to log base. So the newer ones can put them just like they look. But log base will do the log of 30. So the 30 is up higher. So that's how I always know it's on top of the fraction. And then the log on the bottom will be the base, which is 4. Y'all, if you push that in your calculator, either way, you're going to get a 2.4534. Okay, so it's not bad. You just gotta remember on these logs, close those parentheses before you hit division, okay? All right, y'all, now we're about to get into some properties here. So question 15 wants me to express as a sum. So I got log base 18 of 18 times 324. So you write products as a sum. And if it was division, we would write our division as differences or being subtracted, right? So all you got to do is distribute this log 18 to both of these factors and put a plus in between them. So that'll give you log 18 of 18 plus a log 18 of that 324. It's rewritten as a sum, so we're done. 16 says express as a product. So this is using that power rule of logarithms. So I got a log base P of Z to the 19. So do y'all remember doing these when they say express as a product? There's only one thing they really want me to do to that. Oh, and y'all remember, we done that a lot. I got to take that exponent, and guess what?
You bring it down.
I got to bring it down. So good job. So that'd be what? 19 times log base P of my Z. So anytime they say express as a product, that's all they want you to do. Bring that exponent down and be done with it, okay? All right, 17 says rewrite as sums or differences. So basically, all the properties applied to this problem. I got a log base D of x to the 8, y to the 9, and a z. So since this is all being multiplied, it'll only be sums on here. The only way you'll get subtraction is if it's got division going on, okay? So I'm going to do what I did up here. I'm going to distribute the log D to all 3 of these factors and put plus signs in between them. So log base D of x to the 8 log base d of y to the 9th plus my log base d of the z. So y'all, what would I do next to that?
Bring the exponents down.
I would definitely bring those exponents down. And y'all, I ain't gonna lie, they'll put it, if it's a multiple choice, some of these are multiple choice, and if it is, they're gonna have it like that, which would be wrong because those exponents are not brought down, okay? So you want the choice where the exponents are brought down to the front. And then that'll make that a 9 log d of y plus my log d of z. And remember, those exponents got to be in front of the log. They'll have an answer where they put it next to the results, which will be wrong on those, okay? All right, so here's a nice one. Express as sums or differences again. But y'all watch this one. It's going to have a little division on it. So log base b of p squared q to the 6th over m to the 4th b to the 7th. So here's the thing. If it's on top, it will be positive. If it's on the bottom of that fraction, it'll be written as subtraction. I'm going to distribute the log b to all 4 of those. So I'll get a log b of p squared plus a log b of q to the 6th. Those 2 are on top, they're positive. Minus log b of m to the 4 minus log b of b to the 7th. So these 2 are on bottom, they're negative. All right, so we're going to bring the exponent down on 3 of these. The first 3, I'm going to bring it down. Now, y'all, I'm not bringing the exponent down on this one at the moment because I got a log base b of b to the 7th. My log base matches the base of my result raised to an exponent. So that log b of b to the 7 is just going to equal what?
So
That's it. That's all it's going to be is a 7. So let's bring these ones down. 2 log b of p plus that is what, a 6 log b of q minus the 4 log b of m minus 7. And y'all, your last term on every single one of y'all's is going to end up being a number. They might not have a 7 there, but I guarantee you your base will match that result on that one, okay? All right, so then we had some of the same stuff where we had to simplify. So this one's using the ln. So they got an ln of x squared plus 6x plus 8 minus the ln of x plus 4. So to start off, you want to write it as a single logarithm. So it's being subtracted. So this will be on top. That'll be on bottom. So I have a ln x squared plus 6x plus 8 all over x plus 4. And y'all, this we got to go further to try to simplify this. So on this one, we can't factor the bottom, but we got to factor that top. So the top will factor into 2 parentheses all over my x plus 4. So y'all, what are we going to get here? We got an 8 at the end. We need to find factors of that 8. That'll give me a 6.
2 and 4.
So 2 and 4, and they're all going to be positive on this one. So notice y'all's just going to factor just like mine, and you're going to cancel out one of those factors so that when you're done, you got an ln of an x plus 2. And y'all, it's very important on this one. You must keep the parentheses. Because the whole factor x plus 2 is being affected by the ln, okay? So gotta keep that one in parentheses. Well, let's see. I think 20 was doing the same thing. Let me find where I'm at. All right, 20 is a simplify also. So this one, they're giving us a log. Log of x squared plus 7x plus 6 minus the log of x squared minus 1. So they're being subtracted. So when I write them as a single log, it's going to look like division again. So I'll have a log x squared plus 7x plus 6 all over the x squared minus 1. And y'all look at that. Both of these got x squared terms in them, which means we're going to have to factor the top and the bottom. So y'all on top, it looks like I got factors of 6. That'll give me 7.
6 and 1.
The bottom is perfect squares. And perfect squares always factor into conjugate pairs. So that means one's positive, one's negative. And basically, what number times itself equals 1?
1.
It's going to be a 1 and a 1. And y'all, so the numbers that'll be on y'all's will either be a 1, a 4, which will make that 2 and 2. A 9 would make that 3 and 3. 16, you would have 4 and 4 and so on. Okay. So those are perfect squares, but let's see. Oh yeah, now we get to cancel out that x plus 1 factor. So this one, since I got a fraction left, I don't need the parentheses on top and bottom. Okay. Because this log is of this whole fraction. To where over here, since we had 2 parts, you had to put them in those parentheses, okay? All righty, so now we're going to start getting into some of those equations. So let's start where we at 21. All right, let me get this paper. It starts getting folded up on me. All right, so 21 looks like the next 4 are going to be solving, okay? This would have came out of 9, 6. So I got 2 to the x equals 3. So since I cannot rewrite the 3 using the 2 as the base, I got to take logs of both sides so I can bring that x down. So I would do a log of 2 to the x equals the log of 3. And I did that so I can bring my x down to the front, and I get an x log 2 equals log 3. All right, y'all. So now to get that x by itself, we're going to come in and divide both sides by the log of 2. So that'll equal the log of 3 over here, divided by the log of 2. Now remember, when you do this on the calculator, put those in parentheses and close them. So this side, and it don't matter if you got the old or the new on that, okay? So y'all, when I cancel that out, I get my x is equal to, when I punched in my log 3, close parentheses, and divided by my log of 2, it rounded out to a 1.5850. So y'all on 21, you're probably not going to be able to rewrite your base is this one. So remember, you're going to have to take logs. The log is what lets me bring that exponent down, okay? All right, 22 was a solve. Log base 2 of 5x minus 1 equals 1. So when you got a single log equal to a number, you rewrite those as exponential to solve them. So your base is a 2, the exponent is a 1, and that's going to equal that result of a 5x minus 1. So now I can solve that for the x. 2 to the first would be 2. All right, next we take care of that -1 by adding 1 to both sides. So 3 equals 5x. And then finally, to make that a 1x, I divide both sides by 5. So y'all, those 5s cancel. Let's see, you can't do nothing with that 3/5. So x is going to equal 3/5. So 22, you're going to have to rewrite it just like I did. The only thing they change on these is a few of these numbers, okay? Now we're going to get into some little more complicated ones. How about that? All right, y'all, let's see. 23 wants us to solve log base 5 of t plus 27 minus the log base 5 of t plus 7 is going to equal the log base 5 of a t. So y'all, here's the thing on this one. We got more than one log on this side. So we gotta combine these logs. So since they're being subtracted, it's going to look like a quotient. So bring out that log 5. Remember, the positive stuff, the t plus 27 goes to the top. This one's being subtracted, so that t plus 7 goes to the bottom. And that's going to equal that log base 5 of a t. So here's the thing. I got a log base 5 on this side that equals a log base 5 on the right side. Anytime that happens, that means this result equals that result. So t plus 27 over t plus 7 equals this result, which was a t. All right, so now it's just a matter of solving this to see what these t's equal, okay? So watch this. I always put a 1 under the t and I cross multiply. Easiest way to do a fraction problem like this. So this top, t plus 27, multiplies by 1. Well, t times 1 is t, plus that 27 times 1 is 27. That's going to equal the other product, which is the t plus 7 times the t. So the t times t is a t squared, plus 7 times t is a 7t. All right, y'all, look at that. You got a t squared in this. So we need all this over here on one side equal to a 0. So we're going to subtract t from both sides. We're going to subtract 27 from both sides. So this side is going to be a 0. This side I got a t squared. Let's see, 7t minus 1t will leave us 6t. And then bring down our -27. All right, y'all, I'm going to solve this by factoring, but you could use the quad formula. 1, 6, -27 will be the A, B, C. All right, let's factor this. Negative at the end, so these are unlike signs. I need factors of 27 that'll subtract and give me a 6.
Would it be 9 and 3?
So 9, and the 9 is going to be positive because it's a bigger number. And then 3. So y'all, we got factored now. So now we take both them factors and set them equal to 0. So the first one, I'm going to subtract 9. So I get x is a -9. Second one, I'll add 3 and get x is a +3. So y'all, if you did that, what would y'all put for your final answer?
+3.
+3. That's the only answer you can take. That -9, remember, if you put -9 in for that t and try to find the log of that, you're going to get an error because it does not exist. You cannot take the log of negative numbers. All right, so on 23, you're only going to pick that positive answer And y'all, 24 is going to be pretty much like that because it's another equation. So for 24, I got the log base 3 of x plus 4 plus the log base 3 of x minus 4 is going to equal 2. Now we'll start out like I did a while ago. I got 2 different logs on that left side. So we need to turn that into one log. So we bring out that log base 3. They're being added. So this time it'll rewrite as a product. X plus 4 times x minus 4. All that equal to 2. So remember, subtraction I wrote as the quotient will go. Addition I write as a product. And y'all, I'm going to go one step further and I'm going to FOIL that. And y'all think about this. These are conjugate pairs, so you can shortcut FOIL this. X times x would be an x squared. 4 times -4 is a -16. All that equal to 2. So conjugate pairs, I can always shortcut because the 4x and the -4x always cancel. All right, so now I would do it like we did the one while ago where I had a single log equal to a number. I would rewrite this as exponential. So I got a 3. Exponent 2 is going to equal that result, x squared minus 16. So let's see what we get. 3 squared would be what, a 9? That's equal to x squared minus 16. So y'all think I'll solve this one by doing the square root stuff. So I'm going to add 16. So I get 25 equals my x squared. To solve that, we now take a square root of both sides. So guess what? That x is going to come out. So y'all, what would I put here for the square root of 25?
5.
Yeah. And since I'm only keeping positive answers, I don't care that that could have been a -5 or a +5. I only care about that +5 for that answer. So don't even worry about the positive and negative stuff on this one when you do the square root, okay? All right, then there was 1. So y'all, let me see how this one reads real quick. So 25, suppose that $13,314 is invested at an interest rate of 6.1%, compounded continuously. So before, when we had the semi-annually, the quarterly, and all that, I showed you that formula for A of T. Since this one's compounded continuously, this one uses the formula with the little e. The formula will be P of T, which means really they're looking at interest as like population growth type stuff. That's why it had a P there. So P of T, which is in years from a time, equals my P initial. So that's all this PO means is your initial population, your initial amount, times E to the K times T. K is the growth rate or the interest rate. So my K will be 6.1% in decimal form. And then T is the number of years. So the first thing they wanted me to do to this is give the actual equation I would use to figure out how much money is in that account at any time T. So they would have the P of T part already there for you. We just got to figure out what's going in here. So our P initial is this 13,314 here. And then we got our E our K, remember that's in percent. So 6.1%, how would y'all write that one as a decimal?
0.061.
So 0.061 and then times our T. So this is what Math Lab wants you to do to the first part. So now if I have any time T, I can find out how much money is in that account. And y'all, that's what they wanted us to do for part B. Figure out how much the balance is after 1 year, 2 year, 5 year, and 10 year. So T equals 1, we'll figure it out. T equals 2, we'll figure it out. T equals 5, and then T equals 10. So what I do, I use my value feature on the calculator. Now you could do this 4 times by putting the 1 in for the T, see what you get, 2, and so on. But I like to do it where the calculator does my work. So y'all, I'm going to switch to my calculator, and all of y'all will do this. So I'm going to go to y equals and clear that out. And I'm actually going to put in my equation, which was 13,314. Now, to get the E with the exponent, I'm going to hit the second LN button by the 4. You see that little blue E with the X? That'll put the E on the screen with the exponent. And that's going to be what? A 0.061 times T. But now when you're graphing, your T is going to be X really, okay? Because the graphing will only use X's and Y's. So make that T a X on the calculator. Now, if you got an older calculator, when you hit the second LN button, it's going to bring up a little arrow looking caret. I call it an upside down V, and it's going to open your parentheses. Inside the parentheses, you got to put the 0.061X and then close those parentheses on the older calculators, okay? Because your calculator on the older ones don't jump up and do like exponents like these ones do. All righty, y'all. So let's see. So to get to the value, I would hit second trace. And the first thing is value. So hit enter. And then in the bottom left, it says, what's your X number, which will be for 1 year. I'm going to put in a 1. Now, we got to round these to the nearest cents. So for 1 year, we get $14,151.40. Ooh, that's going to be a 44 because I got a 6 after my 3. Then, now check this out. No, I don't think it'll round on that section. Okay. So now let's go to second trace, hit value, enter again. And this time my X is 2. So rounding that off, I get what? $15,041. Point. Ooh, that's going to be what? A 5.5. And y'all remember, this is an investment. So these amounts got to go up every time, okay? If you get smaller amounts than you had, then we're going backwards. All right, so value one more time on this one. I got a T was 5 years. So I'm going to put a 5 in for my value and enter. That one's going to give me 18,062. What's that? 11. And then one more time for 10 years. And enter. So what's that? $24,503.50. So that stays at 0 because that 4 is smaller than a 5. All right, y'all. So now let's go back. So now part C, and notice this went up every bit. Well, started with 13,000, so it almost doubled at 10 years, but not quite. But guess what part C wants? Part C wants the doubling time. How much time will it take for my $13,314 to actually double? So that was given by this formula, capital T equals the ln of 2 divided by my K. So all we got to know is our K to see how long it's going to take it to actually double. We'll take the ln of 2. What was our K up here? 0.061. And now they're rounding this one decimal place. So y'all, let's go see what that's going to give us. Y'all got it punched in? All right, so quit that screen. So I had what, the ln of 2. So the ln is right here. Put in a 2. Close those parentheses. And then divide by, what was that, 0.061. All right, hit enter. So I'm rounding that one decimal place. So that's going to be what, 11 point. Oh, the 3's got a 6 behind it. So I'm going to turn that 3 into a 4. So that one would round to 11.4. You know, I'm going to put my mode back on float since I ain't worried about that 4-digit stuff on that. So if you're not rounding 4 decimal places in the mode, it'll give you the whole actual answer there, okay? All right, so 11.4 years either way we go. All right, y'all, that looks like everything on that because it was 25 questions. So y'all will be in the same order, same type of questions. So that puts us Wednesday. We can study for our final exam and get that going. And then Monday we can play with that final exam some more. I'll make another whole version of it if I got to, and we'll knock it out again. So Monday and Wednesday will be our last 2 classes with this, okay? So y'all remember, every single thing has to be done by December 11th. And let me say this. I've seen some of y'all that have not got all your tests done. If you got a test that needs to be done, you need to email me and I'll open it for you. Because y'all, them tests are 50% of y'all's grade, okay? And that's quite a bit, okay? So you want to have all them tests done. Even if you make a bad grade, it's better than a 0 for a test, okay?
I think there's another assignment.
Oh, don't worry about 10.2. We did the matrix stuff way back when we did systems of equations. So I'll probably just use that as a bonus for y'all. Is that what you're talking about?
Yes, so if we don't do it, it won't count against us.
No, do not do it at all. And I'm going to go in and I'm actually going to give y'all 100s on all those and do it like a bonus for your homework.
Okay, thank you.
Y'all remember when we did the matrix stuff, right? We hit second on the calculator, and that's where we put in all the numbers. And then we did that row reduced and all that fun stuff. Y'all remember the problems where I had like a pizza with so many grams of cholesterol, and what do we have? Eggs with so much cholesterol, and we had to figure out how much each one had. So that's all the matrix stuff we're worried about, okay? All righty, y'all. So here's the thing. We're going to start reviewing for the final Wednesday. Now the final will I can't use it to replace one low grade, okay? All right, but y'all, big thing is if you got any tests that have not been done, you need to get them open and actually put some kind of scores on those, okay?
Yes, sir.
Put going to sleep up on here, I think.
That's what it sounds like to me.
Let me hit that mute button. How about that?
Sure does.
All righty, so wonder how far they made it through, huh? All right, y'all, any questions?
I was thinking about going back to do some of the bonus questions in the beginning. If I can get to it, will you take it?
Yeah, they'll be in your email. Just search my name in your email and you'll find them.
Okay, thank you.
I also sent one today for test 4.
I got it.
Okay. So yeah, I sent one for every test. Y'all got bonus. That'll add 5 points like that. Bam. Well, that'd be like half a letter grade right there. Okay.
Okay.
All righty, y'all. So let me quit that recording.